Sorry for those of you that are joining us. I'm just doing a quick practice question on translations here. So the question I asked was, we started with f of x. What's the simplest way I can describe the transformation that's happened to get from the red one to the blue one? Has it been shifted up and down? Let me start there. You know, there's only a few things that could happen. It's either been reflected, or it's been shifted left and right. That's a translation. Or it's been shifted up and down. So it's been moved to the right. Okay, so Tarek, you said it's been moved to the right. Let me just try to see something here. For example, this point, are you saying it's been moved like this over to the right and now it's over at this point? Is that what you meant? Suspense is killing me. G, X, and F. Okay, so the other way. So you're saying you meant that it went from here to there, which is correct, but really we started with f of x. We usually start with f of x, function x. It's just standard. So really what you're saying is the same thing as it's been moved to the left. And that is exactly what I'm looking for, okay? So it hasn't been reflected, or at least we don't need to think of it like that. It's moved left and right. It hasn't moved up and down. So we just need a single way to describe this. How has it moved? Well, just look at the distance that it's moved. It's been moved to the left. So let me make this clear. It's been moved left by, well, it's going to 0, so it's being moved left pi over 2. Now pi is just like any other number. Of course, it's a special number, but it's still the same as moving it by a certain amount of numbers, which in this case is approximately 3.14. So we just moved it to the left. So let me get to the point here. It says, describe a single transformation that can be used to go from function f of x to function g of x in the function below. Well, the answer, sorry, I just opened a million windows by accident on my computer. The answer is that it's been moved pi over 2 units left. And the way we look at that, it means that our function g of x is the function f of x. But remember, when we move things to the left, it affects the x by adding it. Yes, Tarek, you got it. Plus 3.14 over 2, or plus pi over 2. So really, I can keep the x black. It's been pi over 2 that I've moved, okay? Let me try to summarize this. If it's left, move left means that we have to add x. Or let me make it more simple. I don't want to confuse you. If we move left, we add. If we move right, we subtract. And this goes back to the idea yesterday that everything's kind of backwards when we deal with translations. All right, my computer is acting up today, so something weird happens. Blame it on the computer, not me. Okay, and that's kind of a summary of that question, that topic we were talking about. Move pi units to the left. Actually, we need to add to the x. In question 4 here, all these workings were technically for this question, so I'm just going to move it up there so that if you look back on these notes, it doesn't confuse you too much. But that's the basic idea. Number 4 is a challenge question. It says, describe a combination of 2 transformations that could be used to go from the first function to the second function. And there's many, many different answers for this. For example, I could move the pi units, to the right and then flip it. There's different ways we could do it. I'm actually not going to cover it. If you're curious about it though, you can feel free to look at my solutions for it later. I just don't want to waste anyone's time by doing something a little bit too tricky without having it ever assessed, okay? So I'm going to move on from transformations. Now we're going to start word problems. Some students really like word problems. Most students do not, because they see the idea of words and they're like, oh my God, oh my God, oh my God, oh my God, words. I don't like this. And they get all nervous. Relax. It's going to be okay. There's only so many different types of word problems we're going to cover in this unit, and we have lots of time to cover them all, okay? So just allow me to lead you through it, and when you have questions, let me know, okay? This is a tricky topic for some students, but we're almost done this entire unit now. So first of all, this is just a keyword box. Tom already talked through that, so I won't talk through it again. It's just reminding you what the language is for addition, subtraction, multiplication, division. These are super important, so I'll definitely mention these. Area of these things. So obviously area is important. Circumference of a circle is of course important. Volume of these things are important. One thing that I feel like is very much missing here is perimeter. So I'm going to write down perimeter here. I guess I should be consistent. Maybe I'll put it in my red. What's the perimeter of a rectangle?
2W.
2 what?
2W plus 2.
So it's 2W plus 2L.
Yeah.
Yeah, so if we had a rectangle, for those of you that, you should never memorize the formulas, although it is obviously helpful. We have 2 L's and 2 W's. So of course, when we add them all together, we get 2 L's and 2 W's, or 2 W's, 2 L's. There's no set way to do it. I'm going to put the L first just because of the alphabet. L comes first, but it makes no difference. So that's, if we need it, which we will, that's what we'll use. All right, and I'm assuming you know what all these shapes are. You know, rectangular prism is essentially a box. So if we have something like looks like this, it's a rectangular prism. Of course, a cylinder is like a can of Pepsi or something. Looks like this. And then a triangular prism looks more like this, yeah? So nothing special there. If we need these formulas, we'll go back and look for them. So I've got a little reference there. Sorry, I need to move something over here. Okay, so the examples, which I don't know if you know this or not, but the examples were done by Tom. So you can go back and watch those videos. And we'll do some fresh examples today, some fresh practice. So the first question, actually, even though it should be simple because it's just talking about numbers and X, I put it as a challenge question because a lot of students get tripped up on this. So I'm going to talk you through it, but I probably wouldn't ask, well, I'm not going to say I wouldn't ask this question. I'm going to talk you through it and see how you feel about it, okay? So let's just see. Write each of the following statements as a function of X. So X is going to be our variable. So I'll get you warmed up here. Given a number, double it and add 7. So X is our number in all these cases. Double it and add 7. So times by 2 and add 7. That's what this is asking for. So we just, that's the first one. It's quite simple, but some of them are a little bit trickier than others. So let's see if we can get through this. Square the given number and reduce it by 9. So what does that mean? Square it means to put it to the power of 2. To reduce it by 9 means to take away 9. So it's x squared minus 9. Divide the given number by 5 less than itself. Divide the given number by what? 5 less than itself. Now it starts to get a little tricky. So 5 less than the number. Divide a given number. So take a number and divide it by what? 5 less than itself. Well, it has to be whatever it is minus 5. So right away, we're starting to get this weird backwards logic. I'm not going to over-explain it because these are kind of special types of questions, but that's what this would look like. Let's look at this. 9 less than what? 3/4 of the given number. So 3/4 of x. So we take 9 away from 3/4 of x. And if we write that out in math, it would be, we need 3/4 of x, and we need 9 less than that. Okay? 9 less than 3/4 of a given number. So some of you might find this very logical. Others might be very confused by this. But I'm just writing it out for you so you have the answers. It's a little bit tricky. This E I'm going to skip because the question's not written well. So that's a little gift for you. F, 3 more than triple the given number is doubled. 3 more than triple the given number is doubled. What does that mean, right? Does anyone have any ideas? Does anyone want to type in the chat what they think this means? So for sure it's 3 more than something. So we definitely have to add 3 to something. Triple the given number, so 3x. And then is doubled is going to be a multiply by 2, but how do we put all these things together? Anyone want to give me a possible answer?
9 multiplied by 2 plus 3.
9 multiplied by 2 plus 3? Are you looking at the same question? I don't think that there's no x in here. Where's our x? You should have an x in there. So Ahmed Al-Aswad, you're thinking 6 plus 6x. Aisha, you're thinking 2 and outside of 3x plus 3. Tarek, the same. Okay, I'm pretty impressed. That's right. Both of those are right. So maybe I underestimated you. Now, I never try to treat you like you're stupid. That's absolutely not my intention. I know I've taught this for quite a long time, math courses, and students often have trouble with this. So the fact that you got that right, I'm really happy about that. So 3 more than triple the given number. So we have triple the given number, we have 3 more than that. That whole thing is doubled. So you could put the 2, the 2 could be also over here if you wanted it to be. The computer is really slow today, it's driving me crazy. But really, I'm going to keep it where it is. Okay, let me see if my computer works any better if I plug it in. All right, so good job. And Ahmed, that was the same answer. You can write both. You could write 6x plus 6 if you wanted, and it would be the same thing. So if you got that all on your own, excellent. I'm happy about that. Okay, let's move on to what I would say are like the trickier questions. I mean, these are tricky, but the other ones are complicated in their own way. And in fact, these questions, all of this section is actually really important for the next math course. So it's like a little introduction to them. Let's get started. Sketch a right angle triangle, or a right triangle. It means a triangle with a right angle base. So that's what it means. With a base of 8, an angle of elevation of theta. Sorry, my pen is really fighting me today. Sorry about this. An angle of elevation means the angle from the x-axis of theta. And express the area as a function of theta. Okay, so we have a few things to worry about. First of all, when we deal with these word problems, we of course we should draw a picture. We should write everything that we've been given. And we should make a note of what it's asking for in terms of formulas. So the area is what it wants, and it wants it as a function of theta. So let me try to explain to you what that means. First of all, what have we been given? We've been given that base is 8, and we've been given an angle. What else have we been given? We've given that area is going to be needed. So we need the formula for area. What's the formula for area of a triangle? You should have it right there at the top of your head, but it's on the previous page if you need it. 1/2 the base times the height. Some students like to write BH over 2. I'm going to recommend you don't do that for now because it's a little bit trickier to work with sometimes, but either one works. What you'll notice here, the area as it exists right now would be a function of base and height. It has base and height in it. That's not what we want. In fact, we want it to be a function of theta only. So we need to use some other information to get rid of or replace b and h. Well, it's going to be easy to replace the b because that's going to be 8. So we need to replace h. We need to replace h with a function of theta. Something just spooked me really bad. My wife came in downstairs and shut the door. And I was like, ah! Okay, so we need to replace h with a function of theta. That's because if we remove the h and replace it with theta, we'll now have area as a function of theta. What information do we know about triangles? How can we use this information, which we actually haven't used yet, to find a theta? Well, what do we know about triangles that has theta in it? It's our trig functions. We have 3 of them. We could use sine theta is the opposite over the hypotenuse. We could use that cos theta is the adjacent over the hypotenuse. Or we could use that tan theta is the opposite over the hypotenuse. And of course, most of you know this as SOHCAHTOA. Which one of these 3 rules will help us get h? Cos. Cos has the adjacent side, which is 8, and the hypotenuse, which we do not know. We don't know the hypotenuse. So in order to figure this out in terms of h, we need to use one of the functions that does not have the hypotenuse in it, which actually is 10.
It will be 10.
10. That's because everything else has extra stuff. Everything else has a hypotenuse. We can't use that. So what we do, this is kind of like our first step over here. We're going to solve for h. So first of all, tan is the opposite over the adjacent, so it's h over 8. We can rearrange that for h. That's just 8 tan theta. I multiplied by both sides by 8. Now we know h. So often what we'll see with these questions, we'll have 2 big ideas. We have one formula that we need to get in a certain form, and we'll have a second, or called secondary formula, which we stick into the first one, composite functions, to get what we need. So let me show you what I mean. This, let me give it a different color. I'm going to replace this information right here. All right, let me show you what it looks like. So this is our second step. Area is 1/2 base 8 tan theta. Okay, I'm just replacing it. Oops, sorry, that's supposed to be a highlighter. My computer is doing really weird things today. Sorry about that. And now we can put all of our information in. Watch this. B is 8, so A is 1/2 of 8 times 8 tan theta. And we can simplify this. I'm just going to make it a little smaller because I've run out of room here. Just simplify. Therefore, area is, what's half of 8? It's 4, and 4 times 8, you should know, is 32. So our answer is 32 tan theta. The first time doing these, I totally get if this is confusing. How would you know what you need to do? Well, you wouldn't necessarily know what you need to do. That's why I'm here. But I'm helping you through the idea, right? Write down everything that you've been given. Write down any shapes or make a sketch of a shape that you think would be important. But more importantly, write down any formulas you think you would need. So let me go back through the question here. It says sketch a right triangle. Done. Base of 8, I wrote down that B is 8, always. Angle of elevation, I put that on my sketch. I need to express the area as a function of theta. That's the most important part. I know I need area as theta. So let me make this crystal clear here. I needed area as a function of theta. Our final answer, I should have written this. Let me move it over. Sorry for those of you that can't move this as easily as I can, but I should have made it crystal clear. A is now only a function of theta. How do I know that? It's because the only variable that's in this expression now is theta. I've deleted the base, I've deleted the height. All I have left is theta. Okay, so before I move on to another question, do you have any questions on this one?
Yes, Mr.
Yes, tell me.
Why you put the theta in the right of the triangle? Why do not put it in the top of it?
Okay, so I'll just use another highlighter. Angle of elevation of theta. That angle of elevation, that's what it means. It means start at nothing, start flat, x-axis, and angle up. So it's this angle here. That's the definition.
Oh, okay. And when we put it up?
We're probably not going to. It has a different name. That's I'm forgetting it now, but it's a different type of angle. Elevation means from the x-axis.
Okay, thank you.
Yeah. Angle of I don't know. Like it's lost. It's in there somewhere. But anyway, is any other questions on this? Next one's, I would say, even a little bit trickier maybe, but it'll be important. Okay, I'll just move on. So let me make this fill the page so we have lots of space to work with. A right cylinder, like a Pepsi can. So obviously that's important information. A right cylinder. I'm going to go ahead and sketch it. It's very easy to sketch these. Has a volume of 2,000. Okay, I'm going to write that down. Express the area of material. So I need the area of material needed to make the cylinder as a function of the radius of the base. Okay, so a function of radius. So first of all, the radius of the cylinder is here, just in case we need it. Okay, that's what the radius of the base means. Top or base, same thing. We need the area. I need area as a function of what? The radius. So when I solve for this, I need, what about centimeters cubed? It's not, sorry, thanks Ibrahim. I actually don't need to write the centimeters cubed because it's not going to affect my answer, but you can write it there if you want to remember it, but it's actually not going to change anything later, okay? So you can ignore the units for now if you want, because everything here is the same units. Okay, so let me get back to my point. I need to express the area as a function of the radius. You'll notice the area as a function of radius, A of R. What is it? I cannot get that directly. I need to do that second. My first thing I need to use other information to replace something. Let me show you what I mean. First of all, what is the area of a cylinder? Well, I'm gonna go looking back at my formula sheet on a couple pages ago. Area of a cylinder, surface area. Wait a second. Why wasn't that given? I'm going to give it to you. I don't think this was given anywhere. It's 2 by R and H. That's the, yeah, it's pi r squared on top, and then there's a pi r squared for the bottom. That would be our 2 pi r squared, and then we get our 2 pi r h as the side. Some of you know where that comes from. I'm not going to go into that today, but I just want to break this up for you. First of all, why is this area not okay? Well, because it's a function currently of r, but also h. And we want it as a function of r only. So we need to delete the h. So we need to get rid of h. We need to remove, let me make it more clear, replace the h. In order to replace a variable, you need to go find a second equation. So in the first, look in the question 2 here. In order to replace this h, we needed to use a second equation. So in order to replace the h now, we need a second equation. What's our second equation going to be? There's a huge hint in the question. It's telling us we know something about volume. So we use a volume formula. So the first step here, what is the volume of a cylinder? I think you already said that. I think you were trying to say maybe pi r squared h. So the volume of the cylinder is pi r squared h. And we can rearrange that. If I want to replace the h, I'll solve this one for h and put it in to my first primary equation. All right. This will slowly start to make sense. You'll see the logic. Okay. So I need to solve this for h. This is v over pi r squared. And at this point, if you like, you can replace v with 2000. You can do it now or do it later. I'm just going to go ahead and do it now. This is 2000 pi r squared. Okay, so when you look back on this, it should make more sense. Why is my pen being so evil today? So I'll make this purple. I'll make this purple. Oh my goodness. That's what I get for trying to be fancy. Now we have our big idea. So let me recap. Volume in 2000. Area is needed in terms of radius. I wrote down my radius. Sorry, I wrote down my area. It was as a function of two things, radius and height. That's not good. I need it as radius only. Use a second formula that you can solve for h, and we'll put it in as a composite function to the area, and it'll replace the h. That's what we've done here. So in part 1, we did that. My second step, I'm going to put the h in. So the area is 2 pi r squared plus 2 pi r. What is h? Let me make it super clear. I'll make it in another color. 2000 over pi r squared. Okay, this is the big idea. Now, look at that new formula. It's a little tricky, you know, it's a bit big, it's ugly. We can simplify things, but notice we have r, r, r. We have area as a function of r right now. There are no more h's left. So we've done what we want to do. Now it's just a matter of simplifying. So let's look at this. This is fine the way it is. But look, in the fraction here, there's an r on top and 2 r's on bottom. One of these can cancel. You should notice that there's a pi on top and a pi on bottom. They can cancel. And then you'll notice there's a 2 and a 2000. 2 times 2000 becomes 4000. And this will be our final answer. Our area as a function of radius is 2 pi r squared plus 4000 divided by r. That's our final answer. So I'll bring this up so you can compare it to the previous question. We did the same basic thing. How do we feel about this?
Mister, if you want to take the R common factor, can we?
It's going to be tricky for this one because you'll notice you could, but not for this question. Because look, this r here, you see that? That's on top, we say. It's not on the bottom of a fraction. Over here, the r is on the bottom of a fraction. That's not the same. If one's on top and one's on the bottom, they can't actually get a common factor. And I wouldn't bother trying to make it one big fraction because it's not going to help you. You've already solved the question, right?
Yes. Okay.
Yeah, it is hard. You'll notice I put challenge here. These are the trickiest questions in the unit. I don't know how difficult a question I would give you on a test. This wouldn't be too difficult to give you on a test, especially once we finish working today. You'll see that I'll do a couple like this, I think. I'll look ahead. Yeah, I've got at least one more like this. So you can get the process. But the big idea, again, I'll do the big idea one more time. Write down all your stuff that you might need. So we know we have an area and a volume. All you really are doing is you're rearranging one to put into the other, and it'll replace things and it'll be done. Okay. In this case, we needed area. So that's the equation we put something else into to simplify it. Okay. So hopefully it's becoming slightly more clear. Okay. So I don't want to move on from this unless I'm sure that everyone's okay with it. Can I get a thumbs up or at least like a thumbs sideways? Is there a thumb sideways in Zoom? I don't think there is. You just type a few dots. I don't know. All right, I'll move on. If I need to come back or you want to see it again after, you just let me know. So this question here, number 4, it says the radius of a circle. So right away, I'm dealing with a circle, so I'm going to draw that circle just in case I want to think about it. Oh, I can finally make this work for me. Yeah. Increases at a rate of 2 meters per second. So this is the radius of a circle. If the radius increases at a rate of 2 meters per second, it means that every second it's going to be bigger by 2. Let me finish the question. Let me finish reading before we write anything for that radius. So we have increases at a rate of 2 meters per second. The radius gets bigger by 2 meters every second. Express the area of the circle as a function of time. Okay, that's one big idea. In seconds. So in the end here, I'm going to need area as a function of time. That will be my primary formula that I had to put something else into, provided the initial radius is 4 meters. Oh, the initial radius is 4 meters. Okay. It's puzzling. The radius of a circle increases at a rate of 2 meters per second, but the initial radius is 4. What this means is the radius over here starts at 4 meters per second, but every second it increases by 2. So it increases by 2 every unit of time, t. So the radius is going to be 4 plus 2t. It starts at 4 meters per second. Sorry, it starts at 4 meters, and every second it increases by 2. So let me just make an aside here. I'll delete this after. The radius at 1 second, or sorry, the radius at the beginning, it's going to be 4 plus 2 times 0, or 4. Of course, at the very beginning, it's 4 meters. After 1 second, it's 4 plus 2 times 1, so it's added 2, so it's 6. So after 1 second, it's another 2 meters. After 2 seconds, it'll be 2 times 2, so it'll be 8. And then it'll be 10, and then it'll be 12, and then it'll be 14. So our formula does work. Every second it increases by 2 meters. Mr. Tom did an example similar to that. In fact, I'm going to keep those workings. There's no reason why I can't. I'll just put it to the side. Because some of you like to see the extra work. I appreciate that. Okay, I'll just put it to the side. Now that I have my radius formula, what am I going to do? I'm going to write down my area formula. That's my primary formula. I'm going to use that radius formula and put it inside the area formula to get like our master equation. So first things first, let's write down our area. What's the area of a circle? You should all have that like right away. Area of a circle is not 2 pi r, it's pi r squared. Pi r squared. Some students confuse these and they don't know which one's area. Well, there's a very easy way to know if it's area. Area has square units. It's got to be the one with the square on it. The other one's circumference, or the length of a circle. Okay, so what's my problem? I have a radius. I've got radius here. I need to take this and put it inside and delete it or replace it. And as soon as I replace it, I'm almost done this question. There's really not much left to do. So area is pi r squared. Well, r is 4 plus 2t squared. And there's no need to expand that. We're actually done. So I'm just going to rename that area of a function of time. Sorry guys, my pen is fighting me hard today. I don't know what I did to make this angry, but it's angry, folks. This is our area formula. I can put any time into this and it will give me area of the shape directly. So it will give me the area after 1 second, after 2 seconds, after 3 seconds. So we can use small pieces to make one big, really useful formula. How does that sit with you? Is that making a little bit more sense what our process is? Okay, good. So once again, I'm going to just quickly look back at my other questions. I want you to see the big picture. In question 2 here, let me just go on question 2. We wrote the sketch. We wrote down our givens. I wrote down my primary equation. I went and I got my secondary equation, solved that, and put it back into my first equation and simplified. For the second part, oops. For the second question, I want you to prove to you that I did the same steps. Wrote down my sketch if I had one, wrote down my given information, wrote down what I needed, put down my primary equation, realized I needed to replace something, used a second equation. I put that second equation into the first equation and simplified. Same exact steps. Here, same idea. I didn't need to do anything too special to get the second equation here. It just popped out. So I took that and replaced it into the primary equation and I was done, okay? I just took this and put it in for radius and I was pretty much done. All right, hopefully that's clear. So I'm going to give you question 5 to try. A circle has a radius of 6 centimeters. I'll draw a quick sketch for you. Circle has a radius of 6 centimeters. There's no reason for that to be black. Radius of 6 centimeters. If the radius is reduced by x centimeters, express the area of the new circle as a function of x. So we need area of the circle as a function of x, okay? Take a few minutes. This is a very, very small question. It's just a matter of thinking through it and you'll be done, okay? See if you can get the answer. Take 1 or 2 minutes if you need it, but I want to see some answers in the chat. So one of these answers is correct. Two of them are not. I think I prefer pie. Strawberry rhubarb. I don't think you get rhubarb here very easily. The first one is correct. The first one is correct, and I'll show you why. First of all, we have our area equation. Area is simply pi r squared. If we want it in terms of x, we of course need to replace the r. So I'm just going to go hunting for a second equation. R here, it says r is reduced by, radius is reduced by x centimeters. So it's originally 6, it's reduced by x centimeters. So that's where that comes from. That'll be our first step. I'm going to just take r as it is, put it in for r in the second equation. So that'll be one step. A as a function of x is pi 6 minus x squared. So, very good. To those of you who got that one, excellent. You've got the basics, you've got the main idea. It's just maybe you can't handle the bigger questions yet, but this is the main concept. This is what we're working on. The reason why the second one here is not right is because whoever gave me that, that's circumference. So you had the right idea, but you used the circumference formula by mistake. The second one here, in the chat, it was a multiply by 2. I think you meant power 2, but you should have used shift 6 instead of shift 8. Okay, so that's not multiply, it's the first one. So very, very good. To those of you who tried it and got that, you've got the basic skill set. We just need to keep working to see if we can build on that. So let's do just that. Let's keep building. 6. A rectangle has an area of 8 meters squared. Let's see if it'll take my rectangle first time around. It always puts it sideways. Awesome. 8 meters squared. So the area here is 8. I'm going to ignore the values. Sorry, the like meter squared. I don't really need it because everything's in the same units. Express the perimeter of the rectangle. Oops, sorry. Perimeter of the rectangle as a function of the width. So in the end, I need perimeter. Oops. I need perimeter as a function of width. What is it? Well, let me write down what I know. I know that this is length and this is width. And I know that area is 8. Why is that important? Well, you'll see very quickly. Perimeter is, we talked about this before, 2L plus 2W. 2 length plus 2 width. I need to replace, which one? Well, I need to replace L because I don't want it as a function of length and width. I want it as a function of length, width only. So use a secondary equation. What's our secondary equation going to be? Anyone? It's telling us right here I have area to work with. So I'll write down area. Area of a rectangle. Super easy. Length times width. Rearrange that for the variable I'm trying to delete or remove, L. So that's A over W. Make sure you tell me if I'm losing you here. And we know that area is 8. And so we can remove it here if we want to. And that means length is actually 8 over W. Now that I have that, I just stick it back into the formula. And that's what I'll do. Perimeter is 2 times 8 over W plus 2W. And I will, I'm going to simplify that a little bit because I don't like having that kind of ugly fraction. But that's the main idea. You would have had most of the marks there if you stopped there. But let's just simplify. So also, I should have mentioned, that's already just a function of W. Just going to move that P over a little bit just to stick a W next to it. And then I'm going to simplify. So in the chat, I'm seeing 8 over W plus 2W. You got that, Tarek. But try to simplify. Let's try to simplify this. How do we do it? Well, P of W, I'm going to, wait a second. I'm looking at my solution, making sure that I didn't get something wrong. Length times width. Length is area over width, 8 over W. Yeah, that's okay. Actually, yeah, let's just do this. It's probably okay. There's really no need to match those together after this point. Sorry, I thought I was going down a different path, but it was easier than I thought it was going to be. So that's our final question, or sorry, that's our final expression. You should know what these things mean. What it means is we can now find the perimeter of the shape just by putting in width. So if we put in width to be 1, it will pop out the perimeter directly. It skips length entirely. So these things are pretty useful. It's ways of removing extra information from our equations and making the equations kind of like more powerful or more simple, more elegant. All you really need to worry about though is how do we replace things? So we needed to replace L. I went over here and tried to replace it and then came back and replaced it. Halas. How do we feel about that? We've only got one question left. Well, we have more than one question left, but I don't know if I'll do the last two. They're quite tricky. Any questions on 6?
No.
Okay. I hope you can see the big picture. You know, the first time around, it was like, what? How am I supposed to know? Where are these formulas coming from? How do I know to, really you're going to put it into the other one? But now we've done it the same thing every time. You should hopefully see that there's a very clear pattern here. So let's move on to question 7. Ahmed and Hind stand 4 meters apart. Ahmed holds a helium balloon, which he releases into the air. It rises vertically at a rate of 1.5 meters per second. Express the height of the balloon as a function of time. Express the exact distance between Hind and the balloon as a function of time, t, in seconds after the release of the balloon. Okay. I've got to draw a picture, because if I don't draw a picture here, I'm not going to have a clue what's going on. So I've managed to figure out that this is a triangle. The reason I know that is because they're standing 4 meters apart, and one of them is letting go of the balloon, and it's going up. So if they're standing apart and one is going up, what shape does that make? It makes a triangle. So let's write down the information that I know. I know that this is 4 meters in between them. It's kind of driving me crazy that it's not perfect here. 1 second. That's better, I think. 4 meters apart. By the way, Ahmed and Hind, let's make a note of who's who. Ahmed releases the balloon, so this must be Hind here, and this must be Ahmed over here. And it rises vertically at a rate of 1.5. Do you remember what we do when we deal with rates? When I said it was a rate, when I had a speed before, what that looked like? I'll show you. That's our H. Our first question is answering that, by the way. Express the height of the balloon as a function of time. Height as a function of time. We did it earlier with radius. We just take the speed and put a t value next to it. So it's 1.5 times t. So this height, really, we'll make it blue so you can see it's actually going to relate back to this. I think that's all we can really do for now. That's all because of Ahmed. Okay, so yeah, this is the first question. The first one was very easy. Height of the balloon is a function of time. Well, it gave us directly it rises vertically at a rate of 1.5 seconds. So that's where that comes from, okay? That's this guy. And notice that it's actually, this would get bigger and bigger as time went on. But we don't really need to worry about that. So Tadek, you're saying 1/2 for 1.5 t. I don't know how you got that. But we'll see. We'll see what happens. Maybe there's more than one way to get these. We'll see. Let's try B. I've got A done clearly. Express the exact distance between hind and the balloon, as a function of time t in seconds. So I'm going to make that, what color should I make that? I'll make that purple. The exact distance between hind and the balloon, that's going to be the hypotenuse. That's D. Express that as a function of time. So get the hypotenuse as a function of time. What's our easiest way to get the hypotenuse if we know the legs? You know, if you know what the triangle is, you should just be able to use Pythagoras. There's more than one way to do this, but Pythagoras is probably the easiest way. I'm just going to erase this just for a second. You need D, which is the hypotenuse. Not every student will remember that, so I just want to do that. So I'm going to use Pythagoras. Now, Pythagoras, I certainly hope you know what that is. We did a lot of it in the first unit. One of the legs plus the second leg equals the square of the third leg. So let's put these in relating to our diagram. Actually, I'll rewrite it. I'll just write it like this because I know where I'm going with this, but same thing. Which one is our C? Well, in this case, C is going to be that distance, D. So D squared is A squared plus B squared. Well, that's 4 squared plus 1.5 T squared. I'll make that clearer. Our triangle, let me use some color I haven't used yet. This is going to be our A, this is going to be our B, and this is C. I know it's D, but standard A, B, and C. Okay, so that's why these things work out the way that they do. That's the hardest part. The rest is just rearranging this. But you'll notice we did a very similar thing even in this question as we have before. We have a question we need the answer to, which is we needed to find the distance D, and we couldn't get it unless we put a second formula inside of it. Okay, otherwise it would have been 2 variables. So let's rearrange this and solve it. So I would say that this is D squared equals 16 plus 1.5 squared is 9/4. I'm going to give a decimal for that, just personal preference today. T squared. Once again, this square is distributed to both things. Some students forget that. Don't forget that. And now we can rearrange this very simply. I'm going to get the root of both sides. And I've got my final answer. That is a function of time only, so I'll write the time. Oops. And that's our final answer. So once again, I can get the distance, so I can put in any time. I can put in 1 second, it'll give me the distance at 1 second. I can put in 2 seconds, it'll give me the distance at 2 seconds. I can put in 100 seconds and see how far away it would be if this balloon went straight up after 100 seconds. But that's how these questions work. So is there anything I can recap on that? Did I lose anybody? Anybody awake? I've said this before, I'll say it again. Pretty much every chat program, like if you have WhatsApp, any messenger, Instagram, whatever, they all tell you if someone's typing. You know, why can't Zoom tell me if someone's typing? It seems like it would be useful, don't you think? You're in a meeting and you want to know if someone actually has something on their mind. You're in a class, you want to know if a student is actually typing, because once I go and do something else for 5 seconds, it's kind of awkward for a student to be like, what about this, sir? Like, it looks like you're kind of like in class when when the instructor like me just finishes explaining some big idea, and then the student's like, sir, can you explain this? And I'm like, I just explained it. Anyway, I'm getting off topic. But anyways, so that's the level of difficulty of the questions that I would expect you to be able to do. The reason I mention level of difficulty and so on is these two questions, 8 and 9, are suddenly like a very big jump in difficulty. And so they are challenge, and they are very much that. They're challenge questions. I would not ask them as normal test questions. And so because of that, I'm not going to write it out. I'm not even going to give you the answer in the video because it's kind of a waste of time. If you want the answers, I'm posting full solutions to the notes today, okay? Now, you might be wondering, what are we going to do for the other 27 minutes of this class? Well, that kind of comes down to whatever you want to do. I am happy to review any topic that we've done in this unit, because this is, of course, the last day on this unit. The assignment's on Sunday. We start conics on Sunday, the next topic. Are there any topics in here in this unit that you would like me to do a few more practice questions on? Because this is your chance for me to do that for you. If you're not sure, I'll just talk it through, and you can just tell me which topic you might want, if any. Functions, independent and dependent. Equations, table of values or graphs. Vertical line test. Checking if a function is a function or not. Evaluating functions. Reading a point from a graph. Graphing using table of values or Desmos. Verifying graphs, which means taking 3 points and checking. Domain and range, which many students are not doing well on really, and the assignment does have 2 questions on domain and range. You have to get the domain and range of 2 different functions. Composite functions. Evaluating composite functions. Inverses of functions. Horizontal line test to check if something has an inverse. Check an inverse by graphing, which you would just do by Desmos. I wouldn't test that on an assignment. Reflections in the x-axis, y-axis, or the origin. Checking symmetry, which means you put in a negative x and, you check the same thing as the reflections, but it maps onto itself, gives back the same function. Even and odd functions, which means you put in a negative x and see what you get. Translations, which means you move the y or the x values around and shift it up and down, left and right. And finally, word problems. Now that sounds like a lot. It is a lot, but every one of those topics in themselves is not actually difficult. I think you'll agree with me. Most of those topics are not tough. It's just a lot of different ideas floating all around in your head. So that's the whole topic. That's the whole unit. Are there any of those that you would like me to review?
The domain and range, please.
Domain and range it is.
Mhm.
Anyone else that anything that comes to mind, you let me know. So let me see. Sorry, I don't like to scroll. I'll pause the sharing so it doesn't break your head. Let's see. I'm scrolling up. Where is it? The one thing about using this program that I use is it doesn't let you jump from page to page. You know, if I want to go back to page 25, I need to go look for it. It's a big pain, actually. But I'll find it. Just one second. You don't need to stare at me while I do this. Let's see. So domain and range, we had two types of questions on it really. We had domain and range directly and domain and range of inverse functions. I'm just going to go back to the very beginning. Okay, so this is starting at page 14. I'm going to give you a modified example of example 4b. Okay, so I'm looking at this one. I'm going to give you a modified version of it so that you can be better prepared to do what I'm going to ask you to do on the assignment. So I'm just going to find some blank space. I'll just put it, I'll put it over here and I'll worry about moving it around later. So let's just say we want domain and range. Domain and range of a given function. Let's say I give you the function, x, square root of x plus 4, let me see, 6, 2. Domain and range of the function square root 2x plus 6. I'm going to do it on paper first. Again, there is no reason why you shouldn't graph this on Desmos. For me, that is way easier. You just look at the graph and you say, huh, bigger than -3. But let's do it by paper and see what happens. First of all, if you want the domain, you need to know what possible x values you're allowed to use. Let's say you know nothing about what the graph looks like. Let's let the math tell us for us. Go underneath the sign. You'll say this is 2x plus 6, yeah? That's what's under the sign. That square root is not allowed to be negative because we're not dealing with complex numbers. So it must be greater than or equal to 0 under the root. So I take the expression in the root and I force it to be greater than or equal to 0. And I solve for x. When I solve for x, that is my domain. So you solve it like any other equation. Move it to the other side. That gives us 2x. Keep the sign the same there, greater than or equal to, -6. Solve this like normal, divide both sides by 2. What you end up with is x must be greater than or equal to, well, what's -6 divided by 2? -3. That is my domain. That's my, it's telling us that x must be greater than or equal to -3. The function must not exist less than -3. So first of all, my domain, I'm just going to, we know it's real numbers, okay? I'm going to allow you to do a shortcut here. Normally for these, we need to have this form, yeah? This is the form that we have for domain and range. And we put some rules inside, or conditions really. Restraints on x and so on. Ignore the blue. I want you to get to the basics. The domain here, we're just going to take the shortest possible answer. And we say that the domain, the x values must be greater than or equal to -3. That is the domain. So in short, if your function is a square root function, take the expression underneath the root, set it greater than or equal to 0, and solve for x. That is your domain. That is the existing x functions for that function. Hopefully that's clear. The range for a function like this. I gave you a shortcut for this. I told you if it had a form that looked like this, I'll call it square root form, radical form. The range is always greater than or equal to 1. Greater than or equal to 0. Okay, so that's the big picture here. That's probably the trickier, one of the trickier types of domain and range questions. I'm going to show you a little sketch here why it works the way it does. The reason this graph has these values is because the graph looks like this. You'll notice the graph exists in the x, it exists after -3. You know, it exists for -3. There's an x value for -2, for 0, for 1, for 2, for 3. there's x values for all of those. But, you know, if I asked you the question, what is the function, evaluate the function where x equals -4. You can't do it. The function doesn't exist less than -3. So it makes no sense. Same thing here, the range. Well, if I asked you to tell me what the y value of the function down here is, the y value, you couldn't answer that because the function does not exist down there. The function only exists when y is greater than or equal to 0. So that's what we mean by range. What are all the possible x values that the function has, and what are all the possible y values that the function has? And I realize I've been doing a lot of this and I didn't even have my video on. So hopefully it was okay. What are all the possible x values? What are all the possible y values? Are we clear on that? Okay, sorry, I saw some questions. What if it didn't have the square root? What would be the range then? Okay, so I'll give you a few choice cases. So I'll call this, question 1. Call this question 2. And these are, I'm just coming up at the top of my head. First things first. This function, when we look at it, we look at the x. We see that it does not have a square, it doesn't have a cube, it must be linear. Linears are easy. They go on forever in all directions. So this particular one looks something like this. You could graph it on Desmos. Is there a restriction on x? Is there any point where you're dividing by 0? Or is there any point where the x would be a negative, we'd have to get a negative square root? No. It can go forever in the x direction, and it can go forever in the y direction. And so if it's a linear function, we say that x is just real values, real numbers, and the range also, the y, is all real numbers. There's no restriction. Okay? So the linear is really easy. I'll do one more in a second, or as many as you want, actually, I'll do more. Hopefully that's clear. There's nothing special to check here. There are no conditions. Once again, there's only 2 things you need to look for. Are you dividing by 0 at any point? Or are you trying to get a square root of a negative at any point? And linear is like a safe function. Let's do another one. What kind of function is this?
Quadratic.
Quadratic. Quadratic. We know that because it has a square. And we know that because this is a -3, it looks like a sad face, downward. If you were to graph it on Desmos, which again you should, you would see it looks like this. And you would see that this value here actually matches the 2. That +2 relates to this 2 here. So we have enough information now to fully describe the domain and the range. The domain and the range. Ask yourself 2 questions, because this is what the domain means. Are there any x values that we are not allowed to put into this function? Is there anything that would give us something that would break the system? In other words, dividing by 0 or square roots? No. So domain is not restricted. It can be anything. That's because any of these x values are okay. I could go on forever. I can go all the way over here and check x values, and it would still give me y values. You know, put 100 in for x. Do you get a y value? Then it must be okay. Put 1,000,000 in for x. Do you get a y value? Then it must be okay. What about y values? Does this function have every possible y value in it, or is there a restriction? Well, I'll answer that for you, and you should be thinking along with me. Of course there's a restriction. The function doesn't exist anywhere above this. Or in other words, there is no function up here. So nothing bigger than 2 exists for this function. So Tarek, you said less than 2. The function exists less than 2. So we'll say that the domain, or sorry, the range must be less than or equal to 2. So the reason that works is look at this function here. You know, the function has a value, y value here of 2. You can have a y value of a 1 or of 0 or -1, -2, -3, -4, -5, -6. All of these values would exist. We could find all the y values. But you can't tell me that this function has a y value of 3 at any point. It doesn't exist above 2. So that's how you figure it out for these types of questions. I'll give you another question because I know what's coming. I'm going to give you just the graph. Oops. I'll keep this on the page so you can see it all. I'll split these up. So what if I only gave you the graph? So I'm just going to take a second to make this. Let's just say I had x equals y squared plus 4. If you have OneNote, by the way, it can be very nice to try. Come on, computer, you can do it. You can do it, let me move you. Okay. So this is our function. Now I probably should have made a note of what that is. This is 5, 10, 15, 20. That's a 4, okay? That's a 4. X equals 4. Can you tell me, just by looking at the graph, what is the domain? What is the range? This should be easier than doing it by equations. You should just be able to look at this and tell me what it is. D is 1. Well, I'm telling you that this is x equals 4, but yeah, okay, let's make it easier here. Let's say that was 5 and this is 10. Okay, just to make it simple. Domain is 1, okay? Well, x and 1, I agree with you there, but that's not enough. Does it exist when x is less than 1? Does it exist when x is greater than 1? Does it exist when x is 1?
Greater than 1.
Greater than?
Yeah. Or equal.
Or equal to. Because there's nothing, it's just a basic parabola. There's no hole here. You know, if this was like empty or it did something crazy at 0, then we'd have to ignore it, but we keep it greater than or equal to. What about the range? We're assuming, of course, that this function goes off forever. So it will get bigger and bigger and bigger eventually.
Or.
All real numbers.
Mm.
Okay? This is the big idea. So I should be able to give you any square root, any basic square root, any linear, any quadratic. So for example, you should be able to get me the range of something like this, or you can give me the range of something like this, or you give me the range of something like this. That's the first one. Something like this. You know, anything like that. There shouldn't be any reason why you can't do that. Because they're all done basically the same way. Anything I can clarify there?
Yes, Mr. Yes, the last thing that we had yesterday.
Okay, so if you want a copy of this, I'll put it online at some point, but you can always just take a picture. You know, if you haven't taken a picture, maybe it's a good idea to take a picture now. It might be faster for you. 5, 4, 3, 2, Hold on. Okay. Get my good side. You get me? Okay. Translations, yeah, is what you were talking about. Let me go find
Yes.
it. Again, I have to scroll through this like some sort of caveman. All right. I think you mean this. Is this what you mean?
Yes.
So what's your question?
Up,
Try again?
up,
I can't hear you.
up, please, up.
I still
The
can't hear you.
question, the question up.
What, this one?
No, more up. This is only the translation.
I don't know. I'm not sure what your question is, to be honest with you.
This one. 18.
Which one? Give me
18.
numbers. What?
18.
This one.
Yes.
I wouldn't ask you to sketch all this because you could show it on Desmos. It was more of an example that was for demonstration to see how translations work. But actually, on that note, I'd actually really like to show you a quick demonstration because I'm not sure I showed it properly yesterday. So let me show you something. So let's just say we had a function. So I'll just call it y. So y plus a equals, I'm going to put some x thing plus b. Let's just say I have a basic square function, okay? Okay, I want to show you how translations work. So we can see here, we have a basic x squared. If I add, sorry, let me put a b here. I don't want to, I want to match what we saw in the notes. Okay. Be very careful that you understand what I'm doing. You'll notice that y on the left has an a. If I increase it, which means if it's y plus 1, the graph will shift down. You see that?
Yes.
I added to it, but it shifts the graph down. That's what it does, okay? Let's put it back to 0. If I move the b, which is touching the x, think about x must be affected. We must be shifting it left or right. If I add a number there, it will shift it left. Because normally it's right? Positive means right, but these translations reverse. So if I add b, it shifts it left. Okay, so that's the big idea here. That's all we're doing with translations. So if I say, I want you to shift it up, you actually have to subtract. If I want you to shift it right, you have to subtract, is how these work. I want it to go right, so I need to take away b. So this is the idea here, okay? So when students look at this, they're like, why is it backwards? Well, that's just the way it is. That's just how it works. So let me do a couple examples so we can understand what's going on here. Okay, so I'll do example 4. Mr. Tom already did it, but just so that we have a clear idea, and this will be, a question like this will be on the assignment. Okay, for the function, this is our original function. What will the function be after a vertical translation of 3 units down? So really all I care about is 3 units down. And a horizontal translation 2 units to the left. So really I have a function, you need to shift it down and you need to shift it left. So what does 3 units down mean? It means that I'm going to end up having an x, sorry, I immediately got it wrong. I'm going to end up having a y, whatever my y is, I need to add 3 because it's this backwards thing. 2 units to the left, Left is normally negative. I must have to add 2. So I'm going to see an x. My x turns into x plus 2. And in this case, my y turns into y plus 3. And of course, y here is actually f of x. Okay, so let me show you how this works. My function, f of x, I've got to add 3 to that, equals. Every time I see an x, I've got to shift it. So I need to replace it with x plus 2. All right, and you need to just simplify. But the big idea, the biggest ideas, the main ideas, you need to know what it means to shift it down. It means you add to the y value, or the f of x value. And if it's shifting to the left, you add to the x. If it shifts to the right, you subtract from the x. It's just these backward ideas. Okay, so I'll simplify this. Let's see, the left side I'll keep the same for now. This would be 2x squared plus 4, 8x. 2 times 2 is 4 times 2 is 8. You can work this out on paper. I'm skipping some steps. I'm just multiplying through here. 3x plus 6 minus 1. And then I'm going to solve that for f of x. Just trust me that that's what the numbers come out to. Of course, you should try it yourself. But the main point of this question was the very beginning, knowing the translation. The simplifying should be the easy part. So we've got x squared, of course, needs to stay where it is. There are no other x squared values. There's an 8x and there's a 3x. So that will give me a 9, 10, 11x. And then, of course, there is 3, which is going to come over to the other side. 8, 6, and a negative 1. So we have 8 plus 6 minus 1 minus 3. So it should give us plus 10. Final answer. Okay. I'll keep that up. I've got 1 minute left. That's enough time to show you, prove to you that this is what I'm saying it is. And then we'll finish. Oops, sorry. New graph. The original graph was 2x squared plus 3x minus 1. I want to pull it down, pull it to the left. So I'm going to put in my second function. 2x squared plus 11x plus 10. That has been pulled left and down. We can see that. We can see that taken any point. Let me zoom in. Left and down, yeah? So I can check my work. Take any point. Let's take this point. Oh my goodness. Take this point, shift it 2 left. 1, 1, 2. And shift it down by 3. 1, 2, 3. Yeah. My new function is definitely what I wanted it to be. So this is confirming it. You don't need to graph that. You do need to know how to do it on paper. All right, I don't want to take any more time than I need to. Are there any final questions? I will end the recording here, so bye-bye, my 9 subscribers. I'm doing this for you. It's been great.